Looks like the clamps have completed opening, so that TE should start retracting back very slowly. And it's very, very slight, but you can see the TE just slightly leaning back away from Falcon 9. The first and second stages are both nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Super chill liquid oxygen is our propellant oxidizer, and that's what's creating those white clouds that you're seeing on your screen around Falcon 9. And that's because the warm, humid ambient air causes the liquid oxygen to turn into gas. First stage should finish prop loading at T-minus 3 minutes in a few seconds here, and second stage will finish at T-minus 2 minutes. At T-minus 60 seconds, Falcon 9 will be in startup. This means that the rocket's autonomous internal flight computers have taken over the launch countdown.
Stage 1, LOX load closed out.
And there's that call out for first stage LOX load complete. Just inside T-minus 2 seconds, we light the Merlin 1D engines. We use TTEB as our ignition fluid. And when it mixes with oxygen, it burns a green-colored flame. We then allow the fuel into the thrust chamber, and the engine comes up to full power for liftoff at T0. Now, the Starlink payload continues to be healthy, and the Falcon 9 team is tracking no issues on the rocket. Weather is still looking good for T0. And the range has cleared the surrounding ground, water, and airspace, and are green for launch. LOX loading should be...
LOX load closed out.
There it is. Stage 2 LOX load is now complete. So now that LOX loading is complete, we will start to clear out the LOX line on the transporter erector. So you should see some venting here in a few seconds. And there you can see on your screen, as I mentioned, those white clouds is from the vent. That's from the venting from the LOX. Now, in just 20 seconds or so, Falcon 9 will go into startup, and Stage 1 and Stage 2 will begin to pressurize for launch.
Falcon 9's in startup.
There's that startup call out. Coming up is the final go from the launch director.
Stage 2 is pressing for flight.
Falcon 9 Starlink LDs go for launch.
And there is that call out that we are go for launch. So all systems are
30 seconds.
All systems are go for launch. Let's listen into the terminal count and watch as Falcon 9 takes our stack of Starlink satellites into space.
Stage 1,
T-minus 15
flight.
seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff.
Stage 1 propulsion
Pupils
nominal.
pitching downrange.
T plus 40 seconds into flight, and Falcon 9 has successfully lifted off from Cape Canaveral Space Force Station, carrying our stack of Starlink satellites to orbit. We're now throttling down our engines in preparation for max Q, which is maximum aerodynamic pressure. This is the largest structural load that the vehicle sees on ascent. We've got an awesome,
Supersonic.
awesome view of first stage of Falcon 9 there on your screen.
Max Q.
There's that call out that we've passed through Max Q. Now, in about a minute, we'll have 3 events happening within seconds of each other. The first will be main engine cutoff, or what we call Meco, followed by stage separation and SES-1, or second engine start 1. Now, Meco is where we shut down all 9 of the M1D engines on the first stage to slow the vehicle down in preparation for stage separation. And stage separation is where the first stage separates from the second stage.
Vehicle is following a nominal trajectory.
Good call-outs there. First stage will then make its way back to Earth and attempt to land on our drone ship, Just Read the Instructions, while stage 2 continues its journey with the third event being second engine start 1. And that's where we light up that MVAC engine, and it will propel the second stage with our Starlink satellites to orbit. Now we're just about 10 seconds or so away from those 3 events. That is Meco, stage separation, and SES-1.
Meco.
Stage separation confirmed.
MVAC ignition.
And there we just had Meco and stage separation. On your right-hand screen, you're looking at that MVAC engine on the second stage, confirming SES-1.
Propulsion nominal.
And a good call out that stage 2
Both
is
vehicles
nominal.
continue to follow nominal trajectories.
Both vehicles are nominal.
Separation confirmed.
And there you can see on your screen the fairing halves have been deployed. They are now making their way back to Earth, and as a reminder, we will be attempting to recover the fairing halves today with our recovery ships Go Searcher and Go Navigator.
All right, as stage 2 heads towards its targeted drop-off orbit, stage 1 will execute 2 burns in order to make its way back to Earth. The first is the entry burn, where 3 of the Merlin 1D engines will reignite, and this helps slow the stage down as it re-enters the upper part of the Earth's atmosphere. The second burn is the landing burn, and this is a single engine burn that brings the vehicle speed down rapidly in order to land on the drone ship. We're about T plus 4 minutes into flight, and if you're just catching up with us, we had a successful launch of Falcon 9 from Cape Canaveral, Space Launch Complex 40. If you're looking at a live view of the Falcon 9 Stage 2 as it delivers our Starlink payload to orbit. Stage 1 is cruising back to our drone ship, Just Read the Instructions, in the Atlantic Ocean. Now we'll continue to watch Stage 2 here on a nominal ascent for a few minutes. As a reminder, the Merlins on the first stage are optimized for sea level, and these achieve around 190,000 pounds of thrust during ascent and descent. The MVAC engine is optimized for vacuum and achieves about 220,500 pounds of thrust on the single engine. The Starlink constellation is in low Earth orbit, or LEO, at around 550 kilometers. Now, most geostationary satellites are at 1,000 kilometers altitude, and these are the general satellites that we see in most other systems. When the satellites are farther from Earth, the round-trip data time between the user and the satellite, also known as latency, is much higher, resulting in poorer performance for activities like video calls and gaming. And we're about 30 seconds out here from entry burn. As a reminder, Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage on stage 1, using nothing but, that guide it back during its re-entry to the ground.
Stage 1 entry burn startup.
And there we go, we have entry burn start.
Stage 1 entry burn shutdown.
Beautiful, and entry burn cutoff. Stage 1 is going to continue its descent to our drone ship. Just read the instructions. As stage 1 continues to descend, it uses occasional bursts of nitrogen gas for attitude control, and sometimes you can see this, although in the darkest night we may not be able to. To land, the Falcon 9 first stage is also equipped with 4 landing legs made of state-of-the-art carbon fiber and aluminum honeycomb. These are placed symmetrically around the base of the rocket and deployed just prior to landing. After first stage landing, stage 2 has a coast phase, then a short burn, and then another coast phase before deploying the satellites. We are about 30 seconds out from landing burn.
Stage 1 landing burn.
10 seconds out. We may see a video cut out here.
Stage 1 landing leg deploy.
All right, and there you can see we've landed first stage on our drone ship. Just read the instructions. This marks our 76th recovery of an orbital class rocket and the 6th recovery for this particular booster.
Seco.
And we've had second engine cut off 1.
Lost the signal stage 2 from the Cape as expected.
And we confirmed good orbit. All right, now stage 2 is going to coast for this orbit in the next 35 minutes or so. While that happens, take a look at this animation showcasing where we are in the coast phase. We'll see you back here in about T plus 45 minutes for a second stage relight.
Also signal Bermuda expected. Acquisition signal Diego Garcia.
Welcome back to the webcast for our 21st Starlink mission from Cape Canaveral Space Force Station. So far, we had an on-time liftoff at 3:13 a.m. Eastern Time. Stage 1 came back to land on Just Read the Instructions. That is our 76th recovery of a booster. Now we're waiting on SES-2 coming up here, which is second engine start 2. And this will be a very short, quick burn, just about 1 second, but it will take us to our final drop-off orbit. And there you could see it was a very quick burn, but we did have SES-2 and Seco-2. We had a call out.
Nominal orbit insertion.
There we go. Call out for good burn and a call out for a good nominal insertion. Again, our Starlink sats will ultimately end up in a LEO or low Earth orbit around 550 kilometers above Earth's surface, which is different than your typical geostationary or GeoSat, which orbits roughly 36,000 kilometers above Earth. We have another 15-minute coast phase before we deploy our next batch of Starlink satellites into orbit. And during this time, the spacecraft will start to spin along its central axis, giving the Starlink satellites the momentum that they need to space themselves out over time after they deploy. While this happens, sit back and enjoy some more space jams. We'll see you back here at
signal Diego Garcia expected.
We'll see you back here at T+1 hour and 4 minutes.
Acquisition of signal, Tasmania.
Welcome back to our webcast for Starlink. We had an on-time liftoff this morning. Our first stage booster landed for its 6th time and our 76th recovery overall. Stage 2 completed its 2 burns, and now we are coming up on the deployment of our Starlink satellites. We have a good, nice live view there on your screen, so we should see these deploy here shortly. We've got the sun beaming there in the background. Just about 10 seconds away from payload deploy.
Payload deployed.
Now you can see those Starlink satellites out in space drifting away from second stage. As a reminder, this is just their drop-off orbit. Shortly they will deploy their solar array, and over the next few days and weeks they will distance themselves from each other and use their onboard ion thrusters to make their way to their operational orbit.
And that brings our webcast to a close. Thank you to the range and the FAA for supporting today's mission. If you're interested in Starlink service, head over to starlink.com and sign up. Thanks again for joining us, and have a good morning.